Alrighty, sweet. So, as you guys know, today is going to be focused on classes again. Um, Last week we talked about what classes are, how to define them, and how inheritance works. So today we're going to be building off of inheritance and talking about composition. So these are really similar terms, but they have some critical differences. So inheritance and composition. So would somebody mind defining or just telling me what you guys think of when you think of class inheritance?
Pulling info from one class to another class.
Okay, cool. So pulling info from one class to another. Anyone else want to offer a definition or an example?
I would say it's like if one class has specific methods and another class can inherit those methods and then call those methods. Is that kind of what it
Yeah.
is?
So classes can inherit methods from other classes and call them. We can also inherit attributes too. Um, but yeah, anybody want to offer an example of when you might use inheritance, like a hypothetical?
Just like the example we were using last week. So you have like just a basic class for all employees, and then you have subclasses for specific departments that'll have like unique properties.
Right. So in that case, all employees would be the parent class. Then you could have like managers or like storeroom employee, like etc. Or here we can just say like generic employee, and then those would both be child classes, right? So the way I usually like to think of inheritance is, I mean, it's sort of like you're passing it down. So inheritance occurs between two classes that two classes share something. It can be a method, it can be an attribute, it could be, any measure of things. But if two classes generally share something and you don't want to like redefine the class every single time, you might as well just use inheritance to do the job. So composition is fundamentally a little bit different. And the use cases can overlap, but not too well. So let's see. Okay, here's a good example. So let's go ahead. Let's talk about the employee class. Let's say, right? So, and this is a good. I like to use examples to illustrate things especially for classes. So, let's say you have to create a system to keep track of your employees. So the same exact thing that we did last time. Um, then we could say like every employee has a name, ID number, I don't know, role, etc. And then let's say within your employees, and let's say like some of them uh, work at the counter, and then the employees who work at the counter have ID badges that you also need to keep track of. All right. So, like, really broadly, what are the three things that we'll want to keep in mind if we're trying to answer this or if we're trying to create a system that can help us tackle this problem? So we'll need 3 classes for this, is how we'll start out. What's going to be the most generic class that we want to use?
Employee.
Okay, yeah. So we're going to need, a class employee, and then we'll just like do a pass in there. Then what might we, so that employee class is just going to be like super generic, right? So what class would we need that might be a little bit more specific?
Just be like counter employee or
Yeah. Class counter employee. And I'll do a pass. And then the last one, which is where the composition stuff is going to come in handy, is because so since I said we need to keep track of their ID badges, and ID badges, like they're not simple. Like ID badges have like, probably like an expiration date, like a photo, a barcode, stuff like that. So we'll probably have to make like a class called like ID badge or like a ID badge or something like that. Okay, so let's write out some things for our employee class. So let's do define define init. We'll pass in self. Don't need to pass anything there, and we'll just do like self.name is name. Let's do self name role salary. And we'll do like self dot ID number is ID number. Self dot role is role. Self dot salary is salary. Okay, cool. So let's go ahead and now also make our counter employee class. So let's see, who can I call? Katya, any idea how we can make the counter employee class without doing this whole thing all over again in counter employee?
If I am remembering correctly, I think that you can add after counter employee parentheses employee, so make it inherit from the class employee, and then the constructor would essentially be maybe employee dot init or super dot init, so that you also kind of inherit that constructor.
Okay, so you're saying super and then dot init like this.
I believe so.
Okay. Anybody else have ideas for other ways that we can do it?
yeah, the other way is just instead of super, you just put employee. And I think they kind of work the same. I'm sure there's some differences, but that's kind of what I used on last week's homework. I would just do the class name itself dot init.
Yeah, so that's your other option, right? The first option is going to be, you can write for first, I guess for both options, we actually have to still define an init function and pass in all of the same inputs. So we can't just like leave it with just the super part. But inside of that init function, we have 2 options. Option 1 is we can just do it, directly using using the class init for employee. So in here, we could literally say employee dot init, and then we would still have to pass in all of these commands. Now that is one option. The other option is what Katya mentioned, which is where we can just say super dot init, which ideally should do the same thing. So we could also do super dot init but we still have to, as you see here, we still have to fill all of these fields in. No, I guess we don't have to actually use self for that one. But yeah. Okay, so the difference, is let's say we're going to replace, so we don't need a role now and we don't need a salary because counter employees have defined roles and salaries. So we could say like counter and then the salary is like $20 an hour, let's say. And here we'll just use the employee dot init. Okay, so let's first make sure that this works, right? So I should be able to say like E1 for employee 1 is going to be a brand new counter employee. We're going to name them like Joe Bob, and their ID number will be 100 or random number. And then we can print E1's salary, and let's see what happens just to make sure that everything works as it should. Okay, great. So the salary is $20. That's perfect. We can check the ID number and just make sure that everything's getting passed through. And it looks like it is. Okay, cool. So before we continue, have you guys seen string methods yet for classes? Okay, so I'll just show you this real quick. It's a short detour, but I think it'll be helpful. And if not, well, it's something that you guys will be using later on. So before I print E1, if I just say print E1, what is going to show up?
The whole object.
Exactly, right. So it'll show up with like a memory address and the type of object. Is this helpful at all to like the average user who somehow knows how to use console and run Python in the console? No, because memory address is great. Type of object is great. I don't know anything about E1. I don't know his name. I don't know what he does. I don't know anything like that. So that's where string methods will come in handy. So let's just define a string. Actually here, let's do a string method for employee. So we'll define that using str, we'll just pass in self. And what a string method lets you do is it basically lets you, whenever you print the class or you turn the class into a string, it will return whatever's inside this function. So hypothetically, I could say return, this is an employee. And here, we won't do I'll quiz you guys in the inheritance stuff in a little bit. But here, let's say like we have E2 is just going to be a random employee called like Chuck, random number, manager, salary is like 25. So if I were to now if I were to print out Chuck, the way Python works, it'll say, okay, I cannot print out an object. So I'm going to try turning the object into a string. Is there a string method inside of the class? There is a string method. The string method returns this is an employee. So should print out this is an employee, which is what we define for our custom string method. We can modify the custom string method too. Let's say that we wanted to print out, we could print like say the role plus a space plus the name and then plus like comma ID and then plus their ID number. Oh, we need to do self dots before all of this. That would fix the issue. So if we were to do this, now again, this is why the string method is a method. If we called that for employee when we're printing E2, it'll say, okay, is there a string method? There is a string method. Okay, what does the string method say? I need to print out the role. So it's going to print out E2's role, which is manager, and then the name, which is Chuck, and then the ID and whatever his ID number is, which is 812. And if we hit run, we see that indeed it does print out manager Chuck, ID is 812. So string methods are really, really helpful if let's say you want to double check the contents of something. instead of printing out, print e2.name, e2.id number, e2.name, blah, 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 just create yourself a little string function, which modifies, again, what the class shows up as when you turn it to a string or print it out. And you've got a nice, easy way to error check things. Also, for the next assessment, which likely will have you dealing with classes, I'm not going to give any spoilers, but using a string method is a fantastic way to greatly simplify what your output on the console looks like instead of using a bunch of print statements. So, all right, that's like the small ramble about string method. Now, how can I inherit the string method from employee? Because, well, let me first ask you this. Does counter employee currently have a custom string method? If I do print E1, will it come out nicely formatted like Chuck's did?
It should inherit it, I think, shouldn't it? Because it doesn't have anything to overwrite it.
Well, what do the rest of y'all think?
I mean, I'm assuming you have to do the same thing you did with the net, right? To get it.
It looks like we have two competing opinions. Anyone else want to weigh in? Okay, well, I mean, I'm just glad nobody said this is going to melt down my computer, which is not what I wanted to hear. So this is where testing things out is fun. So let's go ahead and hit the run button and see what happens. Well, look at that. As you see here, it does indeed still inherit the original string method from employee. And again, this is where the inheritance bit comes in handy. So when we're defining counter employee as a child of employee, it will automatically inherit all of the functions and the variables of the previous class. The one thing that it will not do is it will not override it unless we explicitly do so. So if we want to override it, all we need to do is just define a custom string function. As you see here, it's already calling, the employee string function automatically. Like that's just what it knows to do that. But, hypothetically, I could say, hi there, or something else, which is obviously different from what's an employee. And if we run that, we see that it is overridden for our counter employee class because we've custom defined a string function. So the way using these are also any method that has two underscores before and after the name is called a dunder method. Basically, there's a tons of different types of dunder methods. So just type two underscores and you can see there's string. There's the equals function to test if two things are equal to each other. You can do not equals. You can do Boolean operations. You can check the size of something. There's a few more that I won't talk about. But basically, dunder methods are like your basic methods in Python that every single class has. So, a base type is one of the most basic classes you have in Python is an integer. The perfect way of thinking about it. So the integer class has an initialization statement, right? You say float I equals 3. So that's setting the value of that integer to 3. Integers have a string method. It just prints out the integer. They have an equals method. You can check if one integer is equal to another. They have less than or equal to and greater than or equal to methods as well. There's or, etc. So basically, all of these dunder methods are things that classes should have inherently. Now, the way that Python will work when you have a dunder method, or when you're doing a simple operation with a class, like turning it into a string, comparing it to another class, etc. The first thing that it will do is it'll go to your class and check, hey, do you have a custom defined dunder method for whatever thing you're trying to do? Do you have a custom defined string function? Do you have a custom defined equals dunder method, etc.? If you do, it'll default to that. If you don't, like we didn't before, it'll then check, okay, counter employee. Counter employee is a child of employee. Does employee have a custom dunder method? And if it does, it'll default to that. But hypothetically, let's say, employee didn't have one. Then what would you do? Then Python will just resort to whatever it interprets the default behavior as, which is not always helpful because as we saw above, it'll often just print out like a massive memory address, which may not be desired at all times. So anyway, that's a quick, run through about inheritance and specifically dunder methods. Any questions about that before I move on to briefly talking about the difference between composition and inheritance?
I have one question.
Please go ahead.
So, and then when you go to inherit it, you know how we did employee.init. So
Yep.
that little section right there, it's only for the init dunder method then. Like there's no other reason to use it for. Like you couldn't use do the same thing for the string and it wouldn't do anything basically.
Yeah. So, by default, it's already inheriting the string method,
Got it.
right? So, like, we can test that now. So, like, if I type, define string like this, and well, number one, GitHub is smart, so it already auto fills that we want to do the superstring method. But even if I didn't have this, like we did before, and, I hit run it, it will still automatically inherit that behavior because that's just the way the parent-child relationship works in Python. Everything pretty much gets inherited unless you explicitly specify not to.
Got it.
Any other questions before we move on to very briefly? All right, cool. So let's go back to our problem statement. So we need a system to keep track of our employees. We have employees that have a name, ID number, role, salary, and they also have a badge, etc. Now, we already did the cost of the counter employees bit, but now we have a problem. The employees who work at the counter have ID badges that you also need to keep track of. So, let's define an ID badge. So let's define, init. And we should probably give it ID number. We should probably give it we could probably do a name, ID number, photo, expiration. I think that's stuff that goes on a badge. So, we would do self.name is name, self.id number is ID number, self.photo is photo, self.expiration is expiration. Okay, cool. So I've got an ID badge class. There's one problem. Right now, our ID badges are not linked to our employees, and our employees are not linked to our ID badges. So let's try to figure out how we can link these two things together. Now, the approach that you might be most inclined to do, because also we just spent a week learning about this, is let's figure out how to use inheritance for ID badge and counter employee. What do you guys think? Would that be a good idea?
Don't think so, because then you're gonna have to use all the attributes, and it looks like we don't want all the attributes. So we want just one attribute we just want name and ID number. It's kind of what we're sharing, but the other ones we don't want.
Okay, all right. Charles, what do you think? Haven't heard from you tonight.
Yeah, I agree because the expiration date of the ID badge is not likely the expiration date of the employee, so it's not really appropriate.
Exactly. So because we're only sharing a couple of variables, this doesn't really make sense. Number one. Number two, another way to think about it. the counter employee class builds upon the employee class. ID badge doesn't really build on counter employee, and counter employee definitely doesn't build on ID badge. They're like two classes that share something. And this is where composition comes in handy. So what a composition lets you do is it lets you say one class has an instance of another class as one of its attributes. So what do I mean by that? Well, in the previous case with inheritance, a counter employee is a type of employee, but an ID badge is not a type of counter employee. A counter employee has an ID badge. So a counter employee has an ID badge. An ID badge is not, a normal, it's not like a string or like a number or something, right? It's an actual class. So what we're doing is we're essentially like nesting a class within a class. So how can we do this? So first off, let's, try figuring out how we can create an ID badge. So let's just call this like B1. We'll call this like ID badge, and we'll just say like Josh 123. We'll just say like photo.jpg and then like 1224. Yeah, that's what an ID hypothetically would look like. So what we need to do is figure out how to put an ID or how to give our counter employee an ID. Because let's say no other employees have IDs, like only the people working at the counter. Why? I don't know. Let's just do that for example's sake. So what we can do is we can say something like self.badge equals, and then we can make, let's say, a new ID badge, and we'll say name. We can do ID number. Then we can say like name plus .jpg, and then the expiration will be like 1230. Yeah, something like that, hypothetical. So what did I just do? Well, we're still keeping the original init statement. We're modifying it by adding this badge field. Now, what is this badge field? Well, it's adding the characteristic of a badge to your counter employee. And what is badge? Badge is a new type of object that we've just created. And it has the attributes of name, ID number, name, and .jpg, and then, the expiration date. So let's see an example of this at work. All right, so we've got our counter employee, Joe Bob. We'll keep the print statement still the same. But what we should be able to see now is I should be able to say print e1.badge. And if we do that, it should return a valid badge address for us. And as we see here, he does indeed have a badge. So, just so we have like a nice little output, I'm just going to make a string method, and we'll just say like, I string self.id number plus comma, we'll just do like name plus comma plus ID number plus self dot. There we go. Okay, let's see what happens now if we do this. So we see here, well, I'll just fix the format. And we'll add a space. That's much nicer. But we see here that, counter employee Joe Bob it still prints out the same thing. But we now do have a employee one, Joe Bob, our counter employee, does indeed have a badge, right? Which is this thing. So how do we set that up? Because in our init statement, we set the attribute of counter employee, self.badge, equal to an instance of this brand new ID badge class. We can go even further. Let's say that I wanted to find out when Bob's ID or Joe Bob's ID expires. So I can reference his badge, which is E1.badge, and then I can check his expiration date of that badge, which is specifically going to refer to this expiration date in here. And, we can run it and we see Joe Bob's ID badge expires on 12/30. Now let's try doing the same thing for E2, right? Because hypothetically, if the child has a badge, the parent should as well. So let's do print E2 dot badge, and let's see what happens. Whoa, I get an error. Attribute error. Employee object has no attribute badge. Why is that showing up? Well, we only defined the attribute badge. We only defined this composition for the child class. We never defined that for the parent. So attributes are inherited, trickle down is the way I like to think of it. The stuff the parent has, the child gets. The stuff that the child has, the parent does not necessarily get unless the parent starts out with that. So in summary, the relationship between employee and counter-employee is a parent-child relationship. That is inheritance. The relationship between counter-employee and ID badge. A counter-employee has an ID badge. That is an example of composition. Any questions about that?
Just to
I have
clarify,
a- Go ahead, Matt.
If you moved line 37 up to like line 32, would counter employee, or I guess like maybe line like 28, would counter employee inherit the badge attributes as well?
Probably. I mean, ideally it should, because at this point, self.badge isn't just another attribute for the employee class, just like name and ID number and role, etc. So it should hypothetically get self.badge. But let's double check it. So we'll hit run. So first, just checking down here, Chuck, which is our employee, does have a badge, and that's because we put this on, under the employee class. And then because it's being inherited by the child class, it's also getting inherited by Joe Bob, as we can see down here.
Thanks.
Yep. Any other questions?
I just have a question about instantiating the badge within the other class. Doesn't that limit you to the attributes that you're defining in that class? I mean, so the ID badge has additional attributes, and if you wanted to, I guess, have those be created separately, you know what I mean?
Yeah, I know what you mean. So the way that I've set it up right now is, it only locks you into specific inputs. But we could easily change that. So what we could do in, employee is we could add in like a badge field, and we could say self.badge, it's badge. And here, let's see, where's that badge? And then, we'll define, let's say like badge 1 is going to be this brand new badge for, let's say, Joe Bob. We could have the ID number be 1234, and then we'll just say like joebob.jpg. And then what we could do, let's forget the counter employee for a second. Oh, no, that was supposed to be uncommented. Then what we could do, actually, never mind. We'll do the counter employee because that makes a bit more sense. But we have, counter employee has self, name, ID number, and then we'll have him input a badge as well. And then we can put in badge here as a custom input to our function. So this way, you can modify the inputs for badge to be whatever you want. and then you're inputting that into your init statement, like directly. So that's a way around it. Does that help?
Yeah, it does. Thank you.
And again, I mean, just so that way you guys can see that this actually works, I'll just hit run and it works. Any other questions? Okay, so real quick, would somebody mind telling me the key differences between inheritance and composition? Okay, wonderful.
I'll
So,
give it a shot.
oh, thank you, Charles. Please go ahead.
Yeah, so inheritance, you're taking the attributes and methods essentially from a parent and passing it down to a child. For composition, you're taking another class and rather than inheriting things, you're essentially appending them as additional attributes or sub attributes to that class.
Perfect. Thank you. All right, so we're just going to do like a little exercise just because I want to make sure that you guys understand when each use case should be used in practice because it can get a little confusing. So let's say that I have a car dealership and we sell like generic cars and Toyotas. If I needed to make a generic car class and a Toyota class, would you want to use inheritance or composition for this and why? Like just thinking real general. Okay, I heard inheritance. Why inheritance?
Because they're both cars. So the parent class, like the big parent class would be cars, and then generic cars would be a subclass, and Toyotas would be another subclass. I mean, they're both cars, so they share a lot of attributes, right? So
Yep.
There's just minor differences.
Perfect. All right, good. And let's do another maybe one or two examples. Let's say I have a business making computers, and every computer has a GPU. And I need classes for computers and a class for GPUs. Given that GPUs go inside of computers, would you want to have the GPU class be a child class of the computer? Or would you want the computer to be composed of the GPU class and other stuff?
I think you kind of gave it away when you said it was a component. So you'd want it to be composed of, right?
Yep, perfect. All right. I don't want to belabor the point too much, but I think that's honestly about it for tonight. Go ahead and stop the recording, honestly.